So, we continue our discussion on photolithography. We just started to build the concept. So, we now know at least know about this photoresist. We also have heard or discussed or just talked that this photoresist is applied by spin coating, and I promise that as we make progress we will understand what is spin coating. Then we find another term which should be new to many of you, is a mask. So, what is a mask? In fact, a mask, so what is our objective? Let us recapitulate it once again. Our objective is to create some structures like this on the barrier layer, that is on the oxide layer, and in order to do that, what we have done so far, we have on the wafer we have grown an oxide layer, and then we have deposited yes, we have deposited a photoresist layer. But we would like to pattern, and why we have, let me also tell you the philosophy why we have used this photoresist layer and not trying to directly pattern the oxide layer, because there is no mechanism by which we can pattern the oxide layer. We need the help of the photoresist layer to pattern the oxide layer, and that is the whole idea. But where is the pattern? In fact, this pattern you have to create on a piece of item that is called the mask. It is a simple concept. So, on the mask you actually have pattern domains through which the UV light can pass, and some areas the light cannot pass. It is as simple as that. How you do that? When we discuss the mask in detail, we will talk about it. So, this is how the mask looks like. So, now if you bring in the mask on top of your photoresist layer, now you should start correlating what we discussed here. The photoresist changes property upon UV exposure. So, this is how the mask is going to look like. The shaded areas, let us say these areas will prevent propagation of UV light, and the unshaded areas or these areas allow UV light to pass. So, whatever is the structure you actually want to create on the oxide layer, and for that you want to create the same structure on the photoresist layer, you can assume at this stage that you actually create it on the mask. How you create it, it is another question, so I will talk about it later. But mask is that hardware device which actually contains the pattern. And what is the pattern? The functional form of the pattern. Typically, one takes a piece of pure silica glass or a quartz glass, and chromium is a very good absorbent of UV light. So, these patches are created of chromium. So, again the question is, this is again a fabrication issue. Yes, you need some microfabrication platform. What you typically do is you take a glass that is fully covered with chromium and then etch out some of the areas so that the light can pass. And so, you now start understanding one more step in this flow diagram. So, this is the mask. Let us say in this particular figure what we are showing, the area that is gray, it will not allow the light to pass, and the other areas will allow the light to pass, and it can be the other way around also, it does not really matter. And once you place the mask, of course, the immediate next thing that you are going to do is you are going to do the UV exposure, and that is where you need your optical source. This is a very simplified picture. You may not be just doing some patterns for the sake of some fun, but you need to actually make multiple layers of structures to actually make a transistors. Therefore, you need to sort of place a second mask along the contours or the pre-existing structures made in the earlier level. Therefore, you need to have a mask aligner also. So, that I will discuss in brief. This is not very important to know the fundamentals of photolithography, but it is good to know. So, what you do after you place the mask and do an optical or UV exposure, now you see, so this is now you see the color. So, this green color corresponded to the photoresist layer, the original photoresist layer, and now you see that the areas where we claimed that light has passed, I mentioned that this dark gray patch the light cannot pass. The areas where the light has passed, you see I have used a different color. What does it mean? It obviously means that only this area was not exposed to the UV light, and therefore, the photoresist layer over that area does not undergo any change in property. Without knowing whether it is a positive photoresist or negative photoresist, you cannot comment at this stage that the areas where the photoresist layer was exposed to UV light, whether it has strengthened or weakened, but you can definitely comment that over these areas property has changed. Please do not jump to conclusion, and it is very important that you build your concept slowly. What you can claim? You can claim that the areas of the photoresist which fell below the transparent portions of the mask have undergone change in property. Now, what you need to do is you rinse this whole thing in a developer solution. You all know that every material, many material, let us say polymer films have solvents where it dissolves. So, developer is also nothing but a solvent, but it is a very special type of a solvent that if you try to develop an exposed photoresist layer, and that means that what is an exposed photoresist layer? That you have exposed the photoresist layer under a mask. So, that means that the exposed photoresist layer has spatial variation in its property, depending on whether what is the photoresist tone, that also I have not yet defined, I will define it as the time comes. The photoresist upon exposure, the parts of photoresist which has been exposed either might have strengthened or might have weakened, that is not the important thing, but when you rinse or when you put an exposed photoresist layer in a developer solution, the role of the developer is to remove the weaker part of the film, and that is very interesting. So, the developer removes the weaker part of the film. So, in case the photoresist has strengthened upon exposure, developer will remove the unexposed area or the original photoresist. In contrast, if upon exposure the photoresist has weakened based due to chain scission or whatever, then the developer is going to remove the exposed areas. I hope you have understood it, but we will come up with better examples. Thumb rule is, or it is not thumb rule, it is a fact, is developer dissolves the weaker zone of the PR layer. Okay. So, based on this concept, so now we also understand. So, what is the difference between a normal solvent and a developer? Developer is a very delicate combination. In fact, development process itself is a very critical process, that after all this so called, so if you expose, for example, so this is the setup, you place the mask and then you expose it with UV light. What is going to happen along the contours of the patterns of the mask, these areas in the photoresist film are going to expose and change property, while the other areas do not change property. However, they are roughly the same material. So, your developer has to be very selective to only to the weaker part of the photoresist formulation, and now okay, let us look into the schematic we have. So, this is the development process. That is, between this step and this step, what has been done is this exposed photoresist layer has been subjected to development. That is, let us say, in simple terms, let us assume that it has been rinsed with the developer solution for some time, and you see that the area which was not exposed to UV light, that is where the photoresist, the original property of the photoresist is retained, is washed away. So, does it sound a bell? Does it give you an idea as to what type of photoresist you are using? Well, you can immediately say that we are using a type of a photoresist which upon exposure has in fact strengthened, right, which upon exposure has strengthened. As we know that the developer removes or dissolves the weaker part. So, with respect to the exposed part, the weaker portion was the original photoresist. So, this is only possible that if the photoresist upon exposure has strengthened. Had we had the opposite situation, that we use the same mask. So, this is the mask. This is where the pattern on the mask is. You expose it and you have this configuration on the photoresist layer after exposure, and the schematic that we are using in the PPT is just coincidental that I drew it like that, no special reason. Upon development, so this is the development stage. We find that the original photoresist that was resting over this area has been removed. So, what are the conclusions? The conclusion are this particular photoresist upon exposure has strengthened. As compared to the original photoresist, and therefore, it has led to a structure like this. What could have been the opposite scenario? Had the photoresist weakened upon exposure, in that case the structure that you would have got would have been like this. Why? Because upon exposure, these areas in that case would have become weaker, and that is why they have been washed away by the developer, right. So, this picture tells PR used upon exposure has weakened. Now, just compare the structures with the original pattern you had on the mask. You had a flat empty plate, and in which you had this chromium patch only at the central location. If you look at this structure, the pattern in the photoresist layer, this is very important. Just below or just along the contours of the pattern on the mask. What we can say in a single word, in fact, what we can say is that we have created a positive replica. and exactly opposite is the situation here. We have in fact created, so wherever was the chromium layer, there is no photoresist layer. The photoresist layer is surrounding, is present everywhere except the chromium layer where the original pattern on the mask was. So, what have you created? You have in fact created a negative replica. And now, at this point I define the photoresist tone. A photoresist that leads to positive replica is a positive photoresist. And a photoresist that leads to negative replica is actually a negative photoresist. So, now we also understand that photoresist can be two types. And how do we distinguish or classify? A positive photoresist is very simple, from the name itself it comes, leads to positive replica. And this leads to a negative replica. And now we understand that this becomes possible, that a negative replica forms if the photoresist upon exposure strengthens, and a positive replica forms, that is very clear from this picture. I hope you are now able to follow that. A positive replica forms photoresist weakens. So, discussion up to this point we have reached here, but what has happened is that we have been able to create the structure on the photoresist layer, but not on the barrier layer, and that is the basic requirement we have. So, there are mechanisms to now etch away the oxide layer also along the contours of the photoresist layer, the patterns in the photoresist layer. This can be done by hydrogen fluoride or something like that, and then you also remove the remaining photoresist layer. So, you transfer the structure you had created on the photoresist layer into the oxide layer. This part should be bare, and then you expose it into the doping chamber, and then you actually have a doping over this area, the exposed area. And as I already mentioned, that for further processing you need to even remove the barrier layer or the oxide layer. So, this is in a nutshell the entire steps associated with photolithography. I hope you have got some bit of idea about what it is. So, let us see, this is sorry, the video is not running, I will just run it from the root. So, this is where it is. There is some problem, so I will run it sometime later. So, anyway, these are the important steps, therefore, you can see some of it should make sense to you now. Surface preparation, of course, then the deposition of the barrier layer or the oxide layer, then the photoresist application that involves a spin coating. Soft bake, what it is we will learn, then we need to introduce the mask, do the UV exposure, develop. Hard bake is something again we need to talk, and then etch and resist strip is again I will discuss. So, this is in a nutshell. I will since the video unfortunately is not working, I will look into the schematic again. So, these are the steps, and now you understand the different stages. So, the oxide layer, then the photoresist, and these are exactly what we have to do. And I will discuss some of the steps in somewhat detail to make concepts a bit more clear. So, the first thing is wafer cleaning. Of course, you start off, as I mentioned, you start off with a p-type doped wafer, and you would like to first clean it, because dust or any chemical inhomogeneity is going to spoil your entire subsequent processing. So, it is typically washed in all different types of organic, inorganic solution, surfactant solutions, to get rid of all organic, inorganic and metallic impurities. In fact, in semiconductor processing or semiconductor industry, cleaning is an extremely important step, because and I mean, nobody in fact knows what exactly is done, but it is believed that there are a whole lot of steps associated with different solvents. It is cleaned to remove all possible types of contaminants. So, once you have a cleaned wafer, you need to of course first dry it up, and then you start depositing the barrier layer or the silicon oxide layer, which is again a very simple step. You just put it in a oven, in an oxidizing oven, you adjust the time, how long you would like to keep, and you can control the thickness of the oxide layer simply by varying the because the oxide layer grows vertically in the z direction. So, you simply control the time and maybe the oxygen flow rate. So, once your oxide coated silicon wafer is ready, it is now ready for deposition of the photoresist layer, which falls into the category of photoresist application. In fact, the step photoresist application involves several steps, which we will so, these are the photoresist processing steps. It consists of dehydration and priming, resist coating, soft baking, exposure, development and post development inspection. You can sort of learn it step by step. I mean, do not have to really worry about what the industry people say about photoresist processing. So, we understand that you need to have first the barrier coated, the oxide coated silicon wafer comes, and then you need to coat the photoresist. Then the soft baking is a particular step I will mention about it. Then you need to do the exposure, then you need to do the development and things on. There is a bit of discussion in the PPT, since you will be having access to the PPT. So, I will not repeat everything, a bit of discussion on the photoresist, which fundamentally now you understand. So, I will not go into all the detail. Photoresist of course consists of three components, and this is a bit of materials aspect. One is the resin, which is sort of the binder of the film. One is the inhibitor or the sensitizer, as it is called. It is the photoactive ingredient, and there is a third step is the solvent, because you need to dilute it for subsequent processing or spin coating and things like that. These things you can read from this PPT. You now already know, and I am not going to repeat it, that you have positive and negative resist. And the simplest way, I think we sort of understood it in a very simplistic manner. The simplest way to understand is a positive resist is something that gives a positive replica of the mask pattern, a negative resist is something that gives a negative replica, and in order to achieve a positive replica, you actually need to have the resist upon exposure degrading. In order to have a negative replica, you need to have the resist upon exposure strengthening. So, you can just read these things, and there are certain comparisons about what is the let us say the competitive properties between a negative and a positive resist. This is for your information, and these are not very important things, because you can always refer to the manual or the internet and get an idea about the individual properties. SU8 is a very popular resist, which is very widely used, particularly in academia and research. It is used very widely. It in fact is a negative resist. These are some examples of a specific number of a positive resist. Most of the ICs fabricated present day, the industry, they use a positive photoresist. Okay, so that is a bit of idea about photoresist, and then we are now ready to discuss photoresist processing steps. So, photoresist is applied through a method called spin coating, which we will discuss, but where it is going to be applied, and it is going to be applied on, if you remember, on this oxide coated silicon wafer on which the photoresist is going to be deposited or spin coated. So, what is the first step? Just the way before growth of the oxide layer you cleaned your silicon wafer, you need to ensure that your oxide layer after the barrier layer has formed is clean and dry. That is the most important thing, because silica also absorbs a lot of water, and if water is present, that is going to be disastrous for your photoresist processing. So, one of the things that is before the resist is coated, the first step is dehydration and priming. You need to dehydrate the oxide layer. You just heat it up to temperatures between 400 and 800 degrees centigrade, so that all your water gets evaporated away. And after dehydration, there is a bit of detail. One can coat it with a pre-layer. It is not the photoresist, but a layer you can spin coat, which sort of enhances the adhesion between the photoresist and the barrier layer. So, this is it is typically done in the industry, but I mean it is not a mandatory requirement. It is just a functional details, but it is coated with a priming layer which sort of enhances adhesion between the PR and the barrier layer. So, we are running out of time, so I will stop this class here, this lecture here, and pick up the subsequent steps of photolithography from the next class. Thank you.